4.6 homework, systems of linear inequalities. This is day 2. So we've already had the lecture and we already did some practice, and now we're going to do a little bit of the same practice and also move a little bit beyond. So these, I did examples of these for day 1 assignment. I'm not going to do any examples on here. I will remind you though, you can graph both of these in the calculator in the relation screen with the inequalities and everything. You'll see the shading and everything on the calculator. You can turn your grid lines on. If you're in the scratch pad, it's menu 223. Or if you're in a document, it would be menu 263. You could see your grid lines and you could get accurate sketches and shading of all these, oftentimes just using your calculator. Let's go ahead and move on. We're going to do some of these discussion ones together. Number 4. What is the difference between the solution of a system of linear inequalities and the solution of a system of linear equations? Okay, so both of these we're talking about the systems. Okay, so if I have linear equations, let's do that one first. Linear equations, we have the x and y axis, and we have 2 different lines graphed on that. Okay, so let's say I have a line going like this, and let's say I have another line going like this. Okay, the system of a linear equations is just the single point where the 2 lines cross. The reason that is, a solution for this line is any point on the line. A solution for this line, and we're talking about equations here, a solution for this line is any point on this line. So a solution to the system of the equations is a point that is on both lines. And you can either have one solution, you could have no solutions if they're parallel, or if they're the same line, you could have infinite solutions because all the points are in common. So let's summarize that. The solution to a linear equation system, to a system of linear equations, it's usually a point. Okay, that's the most common. Let me zoom out so you can see that. It's usually just a point. Whereas if you have inequalities, you're not dealing with the lines as much. Here's my y and x axis. Okay, let's say I have something similar to these lines again, but now this is, say, a dotted line. And this line has something like greater than or equal to this line. That means it's not the solutions on the line, it's all the points above the line. Oh, I said greater than or equal to. Let me just say it's greater than. Let's say it's greater than this one, okay? So that's all the shading greater than this. And let's say another one is less than this one. Let's say this one, the inequality has a less than. It's all the shading less than this one. And I'll do a slightly different color. Oh, since I made that one a solid line, let's make it less than or equal to. Okay, so a solution to a system of inequalities is not necessarily on the lines at all. If the line's solid, that may be part of the solution, but the majority of the solution is the double shaded area. Okay, so solution to a system of inequalities is predominantly the double shaded area. Now you get into details of if this line is solid and I am talking about a point right here, then yes, that's part of the solution because it's in the shaded area, it's on the line. This line is part of it, right? So that's okay. However, if I was talking about right here, This is not part of that line. Therefore, it cannot be part of the solution to the whole thing. Okay, so that's number 4. Number 5. What can you say, when can you say that there is no solution for a system of linear inequalities? When can you say there is no solution? We just repeated for a system of equations, it's whenever the lines don't cross, they're parallel. What about for linear inequalities? Let me grab a calculator. So what we said was, if wherever there's double shaded area, meaning the shading applies to both inequality lines, then that's the solution. So when would there not be a solution? When there's not any double shaded areas. Not any at all. So let's say I go to my line. Let's say I have something like y is greater than 1. Okay? So y, I'm going to do control equals. Y is greater than 1. That's going to be everything above that horizontal line. Let's do another one. That is y is less than -1. That's everything below the other line, that line, right? Doesn't even include the line. So there is never a double shaded area. All the stuff pertaining to the first inequality is here and up. The second one is down, not including either line. It never is a double shaded area. I can zoom out. Menu 4. Let's zoom out a whole bunch. Let's check it out. Because if you're not sure, you can always zoom out and look. See? There's never a double shaded area. So when can you say there's no solution? When there is no double shaded area. All right.